Okay, over here, again, we don't have a leading coefficient of 1, so we're going to have to do a little bit extra work. So what we could do is we could try to divide everything by this 2 and work from there, right? So we can factor that 2 out, which is the equivalent of dividing everything by 2. So we put the 2 on the outside, put the results in here. So we end up with x squared, right? 2x squared divided by 2 is just x squared. 5x divided by 2, you just keep the 5x over 2. Negative 7 over 2, negative 7 over 2. You just keep that, right? Equals 0. Then you would divide the 2 out, or you can just make it disappear. So we end up with, I'm going to separate those. We end up with x squared plus 5x halves minus 7 halves equals 0. Next, we want to get these constants from the left side to the right side. So we end up with x squared plus 5 half x plus, I don't know, we haven't figured it out yet, is equal to 7 halves. Now what we do is we take half of 5 halves, but we're halving it, right? Looks like a complex fraction. Most of the ones you're going to have in your homework are not going to be this bad. This is especially bad, right? So half of 5 halves is 5 quarters, and we're going to square that, so it's going to get us 25 sixteenths. So we're going to add 25 sixteenths. Honestly, I'm thinking this might have been a typo in my workbook, but it's nice to know how to do the more difficult problems anyways. Okay, so now this fits the pattern, x squared plus 5 half x plus 25 sixteenths. Okay, square root of x squared is x. Square root of 25 sixteenths, again, is going to be this little middle thing before you square it, right? So if you just squared it to get the 25 sixteenths before you squared it, that's always going to be the square root. And that pattern persists throughout this entire thing, right? So 5 fourths. Or you can just figure it out yourself. That's fine too. Okay, and that is equal to, now we have to do a little bit of math over here because we have 7 halves plus 25 sixteenths. I know I probably lost some of you at this point. I know this is an ugly looking problem. 7 times 8 is 56. And 2 times 8 is 16 plus 25 16th. Now the denominators are the same, so they're like fractions, so we add the numerators. So it's 56 plus 25, it's 81 16, right? So 56 plus 25, yeah. Okay, so here we go. So now that's 81 16ths. And what did I put a 1 there? I put a 2 here. Sorry, that's a 2. It looks weird, sorry. Okay, now to get rid of that, to undo the squaring, we take a square root. Whatever we do to one side, we do to the other. Again, technically this notation is wrong, but that's okay. I'm just trying to show you what I'm doing without making it look like magic. All right, so taking the square root of this is actually going to be a plus and minus. So plus and minus. So 81 square root. So this is really going to be, I'll try not to skip this step. So it's really going to be the square root of 81, the numerator, over the square root of 16, the denominator, which gives me plus or minus 9 over square root of 16, which is 4. Okay, so now we have 2 different versions, totally running together at this point. Plus, so we say 5 fourths equals plus or minus 9 fourths. So we say minus 5 fourths, minus 5 fourths, cancel, cancel. We end up with x is equal to negative 5 fourths plus or minus 9 fourths. And now you break it up into both the positive and negative version. Put the positive over here. X equals negative 5 fourths plus 9 fourths. I'm going to have to skip a couple of steps. I'm running out of room. Negative 5 plus 9 is 4. And 4 over 4 is 1. So we got one answer, 1. Yay! Now I'm going to do the negative version over here. And so we say x is equal to negative 5 fourths minus 9 fourths. 9 minus 5, or negative 5 minus 9 is negative 14 fourths. That's a 4, believe it or not. And we simplify that. We divide both the numerator and the denominator by 2. And then what we end up with is negative 7 halves. Negative 7 halves. That did not make it better. Okay. So it looks like the 2 answers for this one is negative 7 halves. And the other one's right there, which should be a 1. Okay, cool. Now we're going to solve the equation using the quadratic formula. So we're going to solve a quadratic using the quadratic formula, which hopefully makes sense. All right, so we're going to break this up. first step is you're going to have to identify, let me put this above it just to make sure this makes sense. Ax squared plus bx plus c equals 0. Okay, so what we need to do is identify our a, which is the coefficient of the first one. We need to identify b, which is the coefficient of your x, right? The first power. So second power coefficient a, first power coefficient, it's the b here, and then finally the constant is going to be the c, right? So right there. So we're trying to identify those. Well, that's an understood 1 there, so we get a 1. That right there is a 9. Right, the coefficient of x is 9. That's their b. The constant is a 14, so in this case, we get a 14. And we've identified a, b, and c. Next, we're going to plug everything into a formula. And that formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And what you really do, I mean, this looks like a complicated formula. It is until you get the hang of radicals, I guess. But you really, at this point, you're just plugging everything in. So wherever I see a b, I plug in my b. So it's negative b. I'm going to put parentheses where I plug stuff in. Sometimes you need to, sometimes you don't. I'm just going to do it universally just to illustrate where I'm plugging these constants in. So that's my b, and that's my b, right? A b here, negative b plus or minus the square root of b squared. Now it says minus 4a. So now I have to plug in my a. A is 1. C is 14. Like that. And that's all over 2a. A being, again, 1. Now, you may have to memorize this. I haven't been talking that much about memorization because we haven't really dealt with that many formulas at this point. We've dealt with a few, but just realize that you are going to be expected to memorize certain formulas. And if not now, then later. So just be aware you have to memorize a lot of formulas. And the sooner you get started memorizing them, the better. If you want to know specifically what you need to memorize and what you don't need to, you should ask David. But yeah, just realize that you're not going to, everything's not going to be an open test. You are going to need to memorize certain formulas. Okay, so let's do a little simplification. Now what I like to do is I like to simplify the radical because that's, most of the simplification actually takes place in the radical. For instance, negative 9 is just negative 9. 2 times 1 is just 2. It's this plus or minus radical. So it's this radical that needs to be simplified, right? So what I'm going to do is I'm going to do a little side work over here, and I'm going to simplify it. Now I'm going to rewrite the whole thing first. Obviously, you don't need to do that. You can simplify quite a bit of this without having to rewrite the whole thing. So 9 squared is an 81. 4 times 1 times 14. So 4 times 1 is 4. 4 times 14 is going to be 56. So this is minus 56. So 81 minus 56 it's going to be a 25. And square root of 25 is a 5. So we actually don't even need the radical here anymore. We just need to plug in the 5. Now, because we have constants here, we need to do an extra step to continue to simplify, right? Because we are going to have the positive version, but we're also going to have to deal with the negative version, right? So negative 9 plus 5, what's that going to be? The difference between 9 minus 5 is 4, so negative 4 over 2. Negative 4 divided by 2 is a negative 2. Over here, we're going to have negative 5 minus 5, so it gives me negative 14. Divided by 2 is negative 7. And so we just plug both of these answers in. And we get our, there we go. Okay, so let's try the next one. Same kind of thing here. We're going to identify our A, B, and C. So A is going to be, you don't see it, so you know it's a 1. B is going to be a 7. And C is going to be a 3. So we plug it all in there. So we say x is equal to negative b, which is a 7, plus or minus the square root of b squared, which is 7 squared, minus 4ac, a being 1, c being 3. That's awful looking. All right, all over 2a, which is 2 times 1. Okay, so let's simplify our radicals, right? So 7 squared is a 49. 4 times 1 is 4. 4 times 3 is 24, minus 24. 49 minus 24 is going to be a 25. And square root of 25 is 5. Okay, cool. We'll go back and rewrite it. Negative 7 plus or minus 5 all over a 2. So now we have to break it off into the positive and negative versions of this. We separate these a little bit. Like that, sorry. We even do this. I know this is getting way messy. I need to learn to write smaller, I guess. Okay, so we have a negative 7 plus 5 over 2. Negative 7 plus 5 is a negative 2 over 2. Negative 2 divided by 2 is negative 1. Awesome! So now we say negative 7 minus 5 over 2. Negative 7 minus 5 is negative 12 over 2. Negative 12 divided by 2 is negative 6. And that means the solution would be negative 6 and negative 1. Now I put these in order of smaller ones on the left and larger one on the right. You don't have to do it in this case, but when in doubt, just do it. You should get full credit for that. And that's that.